right, today we're going to learn about z-scores, Unit 12, Day 2. So remember from last class we did our normal distribution. That's The Greatest Showman, by the way. Good movie if you have a chance to watch that. All right, so z-scores. What the heck is a z-score? Well, here's our normal distribution. We know, this is our standard deviation and so on. And if we go this way we have 3 standard deviations to the right, 3 standard deviations to the left. Well, your z-score are these guys. So this has a z-score of 0, z-score of 1, 2, 3. If you go to the left, that's where your negatives are. So -1, -2, -3. So if we were talking SAT scores, for example, you would want to have a positive z-score somewhere over here. If you have a negative z-score, that's not so good. Okay? Now, we could be in the middle. So 1.5 would be here. But the key here is to understand when we go to talk about percentiles, remember, let me bring this up real quick. So these were the percentiles, if you recall from last class. 50, 84, and so on. So if I have a z-score of 1, my percentile is going to be 84. If I have a z-score of 2, my percentile is 97.5. Now here's the big key. If I'm right here smack in the middle, I'm going to have a z-score of 1.5. But I'm not going to fall right in between these 2 percentiles. How come? Well, if I draw a line straight up, you can see that there's going to be more over here compared to over here. So be careful with that. The z-score is right in the middle, but the percentile is not going to be right in the middle of these 2 guys. Okay? So we're going to talk about that today. All right. So here is something we did last class. Let's look at our math SAT scores. So here is the normal distribution given these conditions. The mean is 500. That goes right in the middle. Standard deviation, 100. So add 100, subtract 100, subtract 100. Okay? Okay. Now, let's do some questions in regard to that. Let's see if I can squeeze this one. Let's do this. All right, so let's cover that up. All right, so what percentile corresponds to a score of 600? Okay, so from last class, we said this was the 84th percentile. So a score 600 would be the 84th percentile. So that means from here this way, that's 84% of your data. Okay? What about 400? Well, a score of 400 is here, so that would be 16%. How about a score of 500? Well, that's right smack in the middle, so that's 50%. And a score of 700, you're going to be right here. So how many would be to the left of that? All right, that's 97.5. Okay? All right. Little one there. There we go. Okay. Now, what percentage of the observations fall between 200 and 300? So that was the 2.5, and this was the 0.15. So between 200 and 300, I'm not sure if I said that correctly, but between 200 and 300, we're right here. Well, that's going to be 2.35%. So remember, this is 2.5 to the left, but when you subtract that 0.15, that's how you get your 2.35. Okay? What about less than 500? So less than 500. So that's from here this way. Well, that's 50%. That's pretty easy to figure out. All right, what if we're greater than 700? So this is where it gets a little tricky. So we're here this way. So greater than 700. What do you think? Well, remember 700 is 97.5, so greater than that would be 2.5. All right, and then final, between 400 and 500. Okay, remember this whole thing plus or minus 1 standard deviation is 68%. So half of that would fall in there, 34%. Okay, so we did a lot of that last class. Okay. So the z-scores, remember, it tells us how many standard deviations any observation is from the data. So if we're on the left side, we're a negative z-score. Okay? If you're on the right side, it's going to be a positive z-score. So again, if I go back to the original, okay, there's a z-score of 1, 2, 3, -1, -2, -3. But we can be in the middle. We can be, 0.5, 2.5, 2.2, anything like that. But if we're on the left, it's negative. On the right is positive. Now, sometimes we need to find that z-score. This is the formula. We take whatever value we have, minus the mu, remember that's your mean, divide by standard deviation, okay, little sigma. All right, so here's our data again. We're dealing with our SAT still. So our 500 is our mean, 100 is our standard deviation. So we want to find a z-score of 650. Well, 650 would be right here. Now, this one's not so bad because that one is right smack in the middle. When we're talking about z-score, we can kind of figure this out rather easily and say 1.5, okay? Because we're right smack in the middle. Now, percentile, that's a different thing, remember. So, let me take this away. Here's the actual way to do that. We take x minus mu, divide by little sigma. Well, 650 is the number we're trying to find. We're trying to find a z-score of 650. So we subtract the mean and then divide all that by standard deviation. Well, 650 minus 500 is 150. When you divide by 100, you get 1.5. So that is your z-score for SAT score 750. I'm sorry, 650. 650, my mistake. All right, let's look at this one. Again, here's our data we're looking at. Now we want to find a z-score of 450. Now, before we do it, do you expect this one to be positive or negative? So here's a score of 450. So what do you think, positive or negative? Negative, because it's on the left side of the average. Okay, so again, here is our, let me make sure that's on there. Z is equal to x minus mu divided by standard deviation. So this time we want to find a z-score of 450. Subtract the mean, divide by standard deviation. So this case we get negative 50 over 100, which is negative 0.5. So that is your z-score if you got an SAT score of 450. Okay, so that was negative. Okay. Now we want to find the z-score of 750. Well, that's going to be way out here. So you think that's positive or negative? Very good. It's positive. Okay. So again, z equals x minus mu divided by little sigma. So 750 minus the mean, 500, divided by standard deviation. We clean this up, we end up with 2.5. So you have a z-score of 2.5. Now, if we're talking math SAT, that is very good. All right, 2.5 z-score is very good. Okay, so now we're going to switch this up and talk about percentiles. All right, so this is where it gets a little tricky. So we already talked about that score of 650 having a z-score of 1.5. Okay, now how do we find the percentile? I'm going to show you two different ways. All right, now the first way is to use what's called a z table. This is a z table. All right, so you can see it's kind of big, it goes up and down, got a lot of numbers here. But if we want, in order to use this, you need your z-score. All right, I'm going to show you another way on the calculator. You don't need that. But if you want to use this, you need your z-score, which is 1.5. Well, here's 1.5. If I just slide over here, there's my percentile. Now, we would need to move our decimal and say 93.32. Okay? But here's your z-scores. Okay? Now, sometimes if you have, let me go up here, it'd be a little easier. Let's say I had 0.11. Well, I would have to go to here. If I had 0.15, I would have to go to here. Okay? So that's how you kind of read this chart. It gets a little confusing, but there's the positive z-scores, and then there's the negative z-scores. I'm going to attach this to the lesson so you'll figure that out. So from the z-table, we got that because it was a z-score of 1.5, it said 0.9332, so that's going to be 93.32%. So again, math SAT score, that's pretty good. That means you did better than 93.32% of the population. Okay, let's bring our friend Ralph here. See if I can squeeze all this in here. All right. So if I want to find the percentile on the calculator, here's what you do. You hit the second button, then the VARS button right here, V-A-R-S, hit that. And then you want to go down to option 2. You want the normal CDF and hit enter. Now, this screen will appear. We need to put, can you guys see that? There we go, a little easier to see. So let me do all that again. It was a little hard to see. So second VARS, option 2. So I'm going to arrow down, hit enter. You can just hit the 2. Now, the upper is the number you're looking for. So ours is 650. Okay. There's your mu. That's your mean. That's your average, 500. And then little sigma. That's your standard deviation, 100. Okay. So you're going to go down. It's going to say the word pace. So you just hit enter and then enter again. There you have it, 0.9332. So from the calculator, from our friend Ralph, we get 93.32% as well. Now, which one do you think is going to be more accurate? The z-table or the calculator? The answer is the calculator. Now, even though they're the same here, the calculator is going to be more accurate because it can round, you know, the decimals keep going and going. Okay? All right. Okay, so we got the SAT score of 450. We already figured that out earlier to have a z-score of negative 0.5. Now, we want the percentile associated with that. So from our z-table, negative 0.5, you're going to get 0.3085. Okay? 0.3085. So that's going to be 30.85%. Okay? Now, let's look at Ralph. All right, so second VARS, option 2. You know, we have a lot of information in there. I just need to change the upper to 450 because that's what we're looking for. The mean is 500, standard deviation is 100. Hit enter, enter, and move your decimal. It's going to be 30.85. So from the calculator, you get the same answer. Now, if you're doing your homework, you only need to give me one answer. If you do it from the z-table, that's fine. If you do it from the calculator, that's fine. All right, now 750. So we found earlier that the z-score here was 2.5. Okay, so from our z-table, 2.5 is going to be 0.9938. 0.9938. So when we move our decimal, that is 99.38%. So if you have an SAT score like that, that means you did better than 99.38% of the population. Okay? What's the calculator give us? Second VARS, option 2. We're going to change that to 750. Everything else stays the same. get the same thing. 0.993, when we round that 7 to an 8, we're going to get the same thing. So calculator 99.38. Okay? All right. Okay, so let's switch gears here. So you guys don't usually listen to CDs much anymore, but we're going to do an example of CDs. Back in my day, that's what we had, CDs. Okay, so we have the mean is 35 minutes. Okay, that's the average. Standard deviation is 5 minutes. So I already set this up for us. So this would be our normal distribution. Okay, all right, so let's say I had 200 CDs in my collection. How many would I expect to have a playing time over 35 minutes? So there's a lot of work involved here. Now, 35 minutes, we need to find the percentile. Now, this says playing time over 35 minutes. So make sure you read the key words there. So that means I want my CDs from here this way. From here this way. That's over 35 minutes. Now, this one's actually pretty easy, okay? Because we know this is 50% this way, so that's what we're dealing with. Well, what's 50% of 200? You're going to say 100. So that's your answer. Okay? All right. So now letter B, let me kind of squeeze this in there. All right. So letter B, we still have our 200 CDs. How many would I expect to have a playing time under 27 minutes? Now this one's not as easy. As you can see, 27 minutes is going to be here. So we want this percentage. Okay, so how many CDs would go in this spot? So think about it. Underneath the 10, if you think about it, is 200 CDs. So there's 200 CDs in everything here. So we just figured out 100 would be this way. Okay, 100 would be this way. Now, 27 is here. All right, so we're going to find the percentile. We need that z-score. So we're going to take 27 minus the average, the mean, and divide by standard deviation. Well, when we clean this up, we're going to get negative 1.6. Okay? So if I want to use the z-table, we need to find the z-score. So here's our z-table. Negative 1.6 is 0.0548. 0.0548. Okay? Now, that's what we multiply by 200. Because we want to find that's how many CDs out of the 200 would fall into that category. So when you multiply that, you end up with 10.96. Now, when we're talking about CDs, we're going to round that up to the nearest CD. So that means 11 CDs would fall into that category of my 200. Okay, now notice this is 5.48%, but remember when you multiply, you need to keep the decimal there, 0.0548 times 200. Okay, so like up here, it was 0.5 times 200 to get that 100. So that's how you find, in a situation like that, how many CDs. All right, last example. So we got Rob and Mary here taking the SAT. Well, Rob took the SAT, Mary took the ACT. Who did better is basically what's happening. Okay, so here's Rob. Here's Mary. So Rob had a score of 1,800. Now the average, the mean was 1,500. Standard deviation was 150. On the SAT, Mary got a 28. Okay, so 21 was the mean, the average. 3 was the standard deviation. Okay? Now, if we want to find out who did better, we can do one of two things. We can find the percentage. So we can just go to our calculator and do that. Or we can find the z-score. Well, let's find the z-score. So Rob had a score of 1,800. We're going to subtract the mean, divide by standard deviation. Okay. When we clean this up, we end up with 2. All right, so that means Rob had a z-score of 2. Let's see how Mary did. Her score is 28. Subtract the mean. Divide by standard deviation. This is going to be 2.333333, and so on. So since Mary had a better z-score than Rob, that means Mary had the better score. Okay, so when you're comparing two different items, you can find a z-score. Now, if we do the percentile, so again, second vars, option 2. Okay, Rob had a score of 1800. The mean was 1500. Standard deviation was 150. Okay, so that was his percentage, 0.9772. So let me write that down, 0.9772. So 97.72%. Okay, so Mary's statistics, second vars, option 2. She got a 28. The average was 21. Standard deviation was 3. She got 99.02%. Okay? Because it was 0.9902. All right, so that's how you compare. All right, now, last class we talked about percentiles. All right. Yeah, let's keep that there. So remember we talked about the middle 68, the middle 95, the middle 99.7. So these are percentiles from the empirical rule. Now, if you look at the Z table, these are the actual percentiles. Okay, you can see slightly different. Okay. Now, does it matter in the grand scheme of things? No, because it's really, really, really close. Okay, but as you can see, this is 0.13, 0.15, 2.28, 2.5. All right, so these are the actual ones. Okay, and you can get them from the Z table. All right, so hopefully that lesson helped. We do need a question of the day, of course. Here we have it. Turn me on my side and I am everything. Cut me in half and I am nothing. What am I? Okay, so that concludes Unit 12, Day 2. Go Cougars!